Hello, my name is Stefan. Welcome to another awesome lecture. So in previous lecture, we mentioned what an address resolution protocol is, and in this lecture, we will look at it in more depth. So in the local network, communication takes place between devices using MAC addresses instead of IP addresses. So they are also called link layer addresses. So ARP is a request response protocol, which means that one device requests a service and the other one replies in response to that request. So suppose that two devices are present in a network with no external internet connectivity. Here, actually, we had diagram of this here. So suppose we have two devices here, which is Typhoon's device and Johnny's device. With no external internet connectivity. So for them to communicate with each other, they need to rely on an underlying protocol, which is known as the layer 2 protocol. So we already briefly learned about ARP tables. So by using ARP table, device can maintain a list of all the devices on a network by using mapping of their IP and MAC addresses. So this is the regular ARP table would look like here. ARP cache in first place, ARP cache MAC address in second place, and as you can see, we have all the ARP tables of. So the Typhoon's Windows 11 has router's ARP table, and the router here has Typhoon's Windows 11 ARP tables here. So this ARP table technique is quite old and was designed without security considerations in mind. So it has some inherent weaknesses that can be exploited, as we will see in later lectures. But first, let's start about learning about what ARP poisoning is. So before we start learning about ARP poisoning, but let's look at the ARP again. So ARP is basically a program on your internet that's installed on your PC that performs all tasks related to address resolution protocol automatically without needing to any input from the user. So to get an address from a machine, it plots FFFF like lots of F, 6 times 2 F's here, I think here. So it puts this amount of F's, which in IRP here, it means broadcast here. So I want to show you something that we learned in previous lecture. Let me actually open my Kali. And yes, perfect. So you remember this example that we did in previous lecture here? Oops, here. So as you can see here, we have lots of S. So these F's mean broadcast in ARP address resolution protocol. So this ACE means broadcast. So let's go to our diagram again. So we use that F's, remember? So here, this F's as a broadcast address. So we are sending this F's to everywhere. And it does this to send to requests to all the active devices in the network while asking the relevant question. So subsequently, the intended device replies with an appropriate answer. So let's look at this diagram here. So now here let's go to previous diagram that we drew in previous lectures. And here, can you see it? Yeah, perfect. So our Typhoon's device sends request, and Johnny's device replies with an answer along with a MAC address. So looks pretty straightforward, right? So actually, there's a design flaw in this protocol. So when a Johnny's device receives a request, so if Johnny's device receives a request, it has no way of knowing whether the information being provided by the requesting device is correct or not. So in this way, you can easily spoof the packets. And now let's go to this example here and see what's changing here, right? So here, actually, let me make it a bit down here so we can see in a zoomed mode. Can you see it clearly? Yes, perfect. And now let's consider a scenario here. So let's say our Typhoon's device wants to communicate with an internet-based device. As we already know, it can't directly connect to internet by itself, right? It can't connect to internet by itself. So it must go through the gateway first the router, and then router connects to this, right? So the corresponding IP and MAC addresses of the device are shown is here. So the Typhoon's Windows 11 and the gateway maintain their own ARP tables. So for Typhoon's Windows 11 to send a request to the external server, it will look inside its own ARP table, which is here. This is the Typhoon's 11 ARP table, to find the MAC address of the gateway device, and this is the ARP table of this gateway device, right? So once it successfully finds the device's MAC address, and as you can see, it found it from here. This is the MAC address of our gateway device. This is information about our router. This is information about our computer, and this is the ARP table as written here: ARP cache IP, ARP cache MAC, ARP cache IP, and ARP cache MAC. So this here represents the step 1 in this diagram, as we explained here. So if there's only one device on the local network, the ARP table in the Typhoon's Windows 11 will look something like that, right? So the ARP table in device of Typhoon's Windows 11 will look something like that. So now, since the gateway is a bridge between a local network and the internet, I will figure out the external IP address for the packet. So then, using its own external or public IP address here, as you can see, we have public IP and private LAN IP here. So, but in Typhoon's Windows 11, it actually doesn't have a public IP since it has the same router 1 IP as the router one, right? So they are sharing the same public IP here. So using its own external or public IP address, it will forward the request to the server located at 89.201.20.19, and this is the step 2. And the server here will process, actually, since we are completing this here, we're gonna make this red, and this means that we completed the steps here. So here, the step 2, actually, instead of making red, it will be much explanatory if we make it yellow. And here, so this is the step 2, right? So the server will process the request and reply to the router. So the server will process the request and reply to the router, and this is the step 3 here. And the router will receive this reply and figure out where the external packet should go to. And how does it figure out where the packet should go? As you may have guessed, it will look at the destination address and destination port. Using its own ARP table, it will see where the respective device is located. And the ARP table in the router will look like this here. It knows our Typhoon's Windows 11 IP address and MAC address. So, and in the step 4, the router will simply forward the reply to the intended recipients. So that's it. This is how our diagram works. So far we have learned how a normal request or response works. And now here we will add an additional player called hacker or pentester. So we learned about how ARP works in this following way. As we already know, devices keep connecting and disconnecting indefinitely. Here, since they are keep on disconnecting and connecting, the ARP program doesn't keep this IRP table indefinitely, right? Another reason for this is the dynamic host control protocol, DHCP. I think you have heard about this, right? So DHCP. So another reason for this is that the dynamic host control protocol, this server, DHCP server, automatically assigns IP addresses to devices in a network. So when a device goes offline, the IP address becomes available again so that it can be assigned to a new connected device. So if our Typhoon's Windows 11 goes offline, and this is the IP address of Typhoon's Windows 11, it could be given to like for example, Jonathan's Kali Linux or Jonathan's Ubuntu here, and they could instead of using in the IP address of Windows 11, this 192.168.1.102 could be given to like Ubuntu system, the Jonathan's Ubuntu system, and whatsoever. So, and as I said, for this reason, devices in a network periodically send ARP responses to other devices in a network to let them know of their current IP and MAC addresses here. So this ensures that all the devices have an updated record of the IP and MAC addresses, and this is how it's done to make the less complications and less like errors in the network here. So now, when a device receives an ARP response, it just updates its ARP table without any authentication or validation. So you can see the problem here, right? So if a device creates an ARP response with a fake information and sends it over to a victim or target machine, the receiving device will update its ARP table with fake information without validating the correctness of the data. So another weakness in the ARP protocol is that it allows us to accept responses, even if it didn't send a request, right? So now, let's look at another diagram here where I drew how attackers work, and now I will explain all of this here right in this lecture. So I hope you're seeing more here. So now, here we have attackers Kali Linux and Typhoon's Windows 11, right? So here attackers Kali Linux, which belongs to the hacker, will generate two fake ARP address resolution protocol responses. One for the victim and one for the gateway router. So it will send an ARP reply to the device of this Typhoon's Windows 11, right? And pretend to be a router. So similarly, it will send a reply to the router and pretend to be a device. So now, so it will simply, like as I said, it will go to Typhoon's Windows 11 and say, bro, I am a router, and it will go to router, bro, trust me, I'm a Typhoon's Windows 11, right? This is how it works. Pretty liar, right? So here, now both device, Typhoon's Windows 11 and the router will update their ARP table with this new fake information. So now, if Typhoon's device makes the if the Typhoon's device, right, will makes the same request as it did in the previous case to the external server, instead of requesting going to the router, the request will go to the attacker. So the attacker can then choose to forward the request to the router, and at this point, the router will think the request is coming from from device A, and in reality, the request is coming from our attacker's Kali Linux device, right? So attacker's Kali Linux device, in fact, intercepting all the network between the router and device. So this is how man in the middle attack type work, and in next lecture we will create an example application with this here. So I'm waiting you in next lecture. Hello, my name is Stephen, and in this lecture we will learn how to build an address resolution protocol spoof program. So before we move on, let's take a look at the ARP tables again in both Kali as well as the Windows. And you can see Windows ARP table in the right top corner of the screen here. And I think, yeah, you can see it. And here we will also check the ARP A here. You can see we have here ETH0, Ether as well, and this is our, and some of this is incomplete, but I think this 128 is belongs to Windows. So as you can see here we have the correct MAC addresses for the router located at 192.168.13.2. Kali here is located at 138, and sometimes you might not see own IP addresses in your ARP packets, but sometimes you can see, so it doesn't make any big difference here, so don't worry about it. So, and our Windows 10 is located at 192.168.13.128 here, and we can see the IP address. So we are in the same network as Windows 10 here. So we can now close the we will just close the Windows, but we will not turn it on or turn it off here. That's it to see fully here. And now what we're gonna do is we will start our project. You can also open the PyCharm here and delete old project, or you can create a new project from the file, a new project here, and that's it. So I suggest to use virtual environment, but you can also use this on your own Python 3 program here. So now what we're gonna do is we're gonna import some of the libraries. Actually, let's import all of the libraries, and so while we are coding our program, the integrated development environment will suggest us what the libraries and packets we want to import. So now let's from scapy.all we will import all here, but here we will this asterisk actually means that we want to import all the modules present in Scapy. So as we learned in the previous lectures, to spoof we have to create fake responses. So first we will create a response intended for the victim, and to do this we will create an ARP packet and see what fields can be set in it. So we will use the my ARP response here, and we will create a new ARP class here. As you can see, we get an error because we have to import the Scapy layers L2 ARP here. So I think if I would increase the size of the text a little bit, you will see better here, and we'll use the custom font 18. Perfect. So now what we're gonna do is, after that we will print this ARP response. In this case, this will not ask any root privileges, so we can run it here. And as you can see here, ARP has 000 says 1. As you can see, it's 108. It ends with 138. And do you remember it somewhere? And as you can see, it's our local. It's our Linux machine's local IP address. So, and after that, we will also use show. And let's see what will change here. And as you can see here, we are seeing Ethernet 10 megabit IP version 4, and we are seeing our IP address and MAC address here. So now the output would look like this, and we can also check this on here terminal and Python 3 main, Python 3 main.py here. Oops. And as you can see here, we are seeing all of the information that the ARP provides us, address resolution protocol provides us. So the fields that we are interested in start from OP here. So OP stands for operation or type of packet. So this is here who has operation, which means that it is an ARP request, address resolution protocol request. So, but we are interested in creating an ARP response instead. So, which is HWSRC here. So now HWSRC, and we also had HWDST and PWDST. As you can see from DST, haven't been set for this packet yet. So now we will make the modifications in this packet in order to spoof the victim. So actually, let me get my pen here. Okay, so we will change the OP to 2, right? Oops, sorry. We will change the OP to 2, and actually we will change the OP to 2, implying that this is a response here and not a request. So and by default this value is 1, which means it corresponds to the who has. So the one is who has, and two is just a response and not a request. And we will also change the PSRC here. You can see here, we will change the PSRC address field to make it equal to the value of the IP address of the router. Since our router is located at here, remember this? Actually, let me open the new tab, and if config, and here our router is located at here. Actually, let me write the ARP A here, and as you can see, our router is located at here, and we will set this field to the value. And lastly, we will set PDST. So we will set the PDST to the IP address of the victim's machine, so which is in this case is our Windows machine, and our Windows machine has an IP address of 128. So we will also set the HWDST address, which is the victim's MAC address, and here this is the victim's MAC address here, so we can see it freely, right? And now here in next lecture you will also write the code for it. In this lecture we actually introduced what we will do to create our project. Actually, this is not a quite simple project that we did in earlier lectures, but this will be like so much bigger than the previous projects here. So I'm waiting you in next lecture. Hello, my name is Stefan, and in this lecture we will learn how to build an ARP spoof program, address resolution protocol spoof program. So before we move on, let's take a look at the ARP tables again in both Kali as well as the Windows. So let's first look at those tables in Windows here. I will open the screen now. Okay, perfect. And as you can see here, we are seeing our address resolution protocol here. Let's actually write ARPA, and that's it. Here, as you can see here, we have use physical addresses and internet addresses here, and here we will also check that in Linux. We will not turn off the Windows operating system, but however we'll just close the screen right now. But actually Windows operating system is running now in here, and now we will go to our Kali Linux operating system, and we will check the ARPA. And as you can see here, the ARP table in Linux and Windows looks like this. And as you can see here, they have the correct MAC addresses for the router located at, let me actually, here, as you can see, they have all the addresses located at 192.168.13.2. So as you can see, you can see it on the Windows operating system as well with the same MAC address. So this is our router, and here this is our, I think, let me if config, and this is our Kali Linux operating system attacker system in reality. It's IP address, and also we have the ether, we have the MAC address of it, and this 128 is Windows 10 operating system, which is the victim here, target machine. And now to spoof these devices, we will take on this problem step by step. So first we will tackle spoofing the victim machine with the MAC address of the router. So this is the IP address of the router, and this is the MAC address of the router. So now we're gonna open the PyCharm here, or whatever your internet integrated development environment is. In this case, it's PyCharm. I think it's one of the best IDEs for Python. And now we're gonna import scapy all and import everything. So this asterisk here means that we want to import all the modules present in scapy. As we learned in the previous lectures, to spoof we have to create a fake responses. First we will create a response intended for the victim, and to do this we will create an my ARP packet packet, and we'll make it ARP class, and after that we'll print this here. So ARP response my ARP packet, and after that, or actually let's, instead of writing this my ARP response, it will be more logical to write like that. So as well as we will write this ARP response, and let's run this and see what will happen. As you can see, ARP who has 0.0.0.0 says this, which is in this case it's the attacker IP address, right? And now the output of course is going to be look like this, and we can also check it from the terminal, and as you can see we got the same result as we did here. And the fields that we are interested, we have to get more detailed information, and in order to get that we're going to use the show method. And we have a problem here because we need to import the escape layers here, and now it's everything. And as you can see here, we are interested from OP here in these 5 addresses. So OP stands for the operation or type of packet. Let me check actually if you can see it. Yes, we can actually close the windows, but it's actually, as I said, in reality it's actually running in the background. You're just seeing the Kali Linux here. And now the OP stands for operation or type of packet. So the who has here operation, this is a who has operation, which means that it is an ARP request, address resolution protocol request, but we are interested in creating an address resolution protocol response instead. So here also we have so we're gonna change this. Remember, this has to be changed. And we also have HWSRC. This is the MAC address of the Kali machine. We can check this by writing ifconfig to verify it, and as you can see, this is the same MAC addresses. And also similarly, PSRC is the IP address of our Kali machine. So HWDST and PDST haven't been set for this packet yet, but now we will make these modifications here. So now we're going to go to Python, PyCharm, and we will create following. We will write following codes here. So my ARP, so we will manipulate and edit this ARP response here. So we'll set it to 2, and I will explain all of these codes right now. And PDST is going to be, we will write the Windows IP for that. So now let's check. Oh, sorry, I opened browser accidentally, so we can close it. And we will gonna check the Windows IP. This is the Windows IP address and the Windows MAC address. And we're gonna go to PyCharm again, and we will write the Windows IP, and we will notify the, for example, the next programmer to, and we will add a comment that this is a target machine and Windows 10, and we also need to set the Windows MAC address. So my ARP response dot HWDST, and here we will copy this here, perfect, and we'll paste this. Oh, sorry, not this. So we will paste this right now here, and as you can see, this is the target machine Windows 10 MAC address here, and this is the IP address. That's it. And after that, we will also need to edit the my Kali MAC. So we will enter this HWSRC, and this is going to be our Kali attacker machine MAC address, and this is here right here. We'll also copy that to it, and attacker machine, and this is the Kali MAC address, and we will also need to set some fake field value, ARP response, my ARP response dot PSRC, and we will set one. Let's actually set the router here. Yes. Yeah. And here we have only crafted the last field, and we will be sending it from the, we can also make a tree here. So we will be sending it from the target machine or attacker machine while pretending to be like Windows 10, right? So once all fields have been set, you can print them to see if they have defined correctly. Now, in order, what we're gonna do is we're gonna delete this print here. Actually, let's copy it, cut it from here and paste it right after this manipulation phase here. And as you can see, this is the output here. We can also check it and verify it from the terminal. We will run clear the console and run it again here. And as you can see here, this is our output. And as you can see here, our OP is changed, right? So this is the output you're gonna see here, but remember, this IP addresses will be different on you, and you need to change this IP addresses according to your network or MAC addresses here. So now let's check this here, and so they are the two different physical addresses here. And now what we're gonna do is we'll go back to Linux here and test this here, and we will also add while loop here. So we go back to Linux, we will add the while loop here. So while true here, while true. So this code will run continuously, and that's it. So after that, we will go back to here and clear the screen and run it again. So sudo python3 main.py here, and as you can see, our loop is working and looping here. And now what we're gonna do is we will go to Windows, and here, as you can see here, use, and we will go to ARPA here, and as you can see here, we have the two same physical addresses here. So now when you run this program, whenever, if you are not using loop here, so you can go, if you are not using loop, you can quickly go to Windows machine before the ARP table gets reset, and you will see that the ARP table of the Windows machine has been poisoned, and that is the ARP table entry shows the wrong MAC address for this gateway. And instead of pointing the actual gateway, it now points to Kali's MAC address. So now let's go to Kali here and check. Actually, we can now stop it, and now we will go to Kali here, and we will use the ifconfig here, and our MAC address is exactly the same as the Windows one. As you can see here, Kali MAC address is now matched to, so they now share the two same MAC addresses in our network, local network here. So this is how ARP poisoning works here. So I'm waiting you in next lecture. Hello, my name is Stefan, and in this lecture we will turn this code into function, and we will also create a new function that we will spoof router as well. So now what we're gonna do is we will just cut this code here, and we will turn it into function like that. Let's actually see here. So now what we're gonna do is we'll do define the function. So we will, so as you remember, this code is for spoof target, spoofing the target here, and after that we're just gonna copy this here. So now we have a spoof target method function, and now we will also add spoof router. So, and we will create a similar function to this as well, but here we will actually change some values, right? And def, so here this was a spoof target, and this is going to be spoof router here. And after that, we will also, for now, we will copy this and we will here. So that's it. And here, this is in, remember in previous here, fake router IP. So here we are pretend to be that IP here, and pretend, and here we will also add fake target, or instead we will write the fake device, and here we will pretend to be that device or that IP here. So, and after that, for example, remember our Kali machine's IP address here. If config, this is the IP address of our Kali machine. And remember, our Windows machine IP address ends with 128. So now we will change this to 128 here. And here we will paste the router's IP address instead of a target machine's IP address. So now this is the router's IP address. As you remember, our router IP address was this here. We will changing to here, and also we will also need the router MAC address. We can find it with ARPA. It was ending with 2 here. So this is the MAC address of our router here. That's it. Now we're gonna paste it here. So we will also change the router's MAC address here. We will changing to here, and this is also this will be stay same, and this is the attacker's machine, which in this case is Kali Linux, and this is the fake device pretend to be that IP. So as the name suggests of our function, this with that code we are spoofing router, so we are pretending that we are some device, right? So in this function we change the value PDST, HWDST, and PSRC, and here complete the program will look like this. Actually, let me delete that lines, and also here, from here, that's it. So here, and after that we will also add if and main here, if name main here, if name here, and main. So this code will work whenever our program starts. Main here, and after that here, as you can see, we get an error here because we need to add this. And after that we will first spoof the victim, in this case spoof the target, and after that we will spoof the router, spoof the router. That's it. So and keep in mind that we will only spoof these devices once for now. To create a permanent spoofing, we can do this codes like loops and continuously send these packets after a certain delay. So this way the ARP tables will not get a chance to reset, and you will be able to permanently spoof these devices, so as long as your spoof program is running. So in order to do that, we will do the while true here, and we will just add here. So in reality, actually, you also don't need to wait or add some delay in it, but we will not add here for now. We will first spoof the target, and after that we're gonna spoof the victim. So the target here. So now let's run this. This might be asking for some permission. As you can see, operation not permitted. So we're gonna open our desk, and now let's go to PyCharm project, go to our project name, and here, that's it. It's clear. Now we're gonna run with sudo with super user privileges, and we will do main.py and Kali here. Oops, Python 3, of course. Python. That's it. And as you can see, we keep sending packages here. And here, let's actually check the internet now. So we will close the internet because you will need to here. And as you can see, when our internet is not working here, right? Let's actually go to myip.com. So our internet will not work for now. So we will now interrupt this, and our internet immediately will come back here. Here. And as you can see, our internet has come back, and let's run it again. Here, as you can see, it's running now. So that's it. So here, now we will also try to spoof these devices once, but we can also try to put an exit condition in our loop. So now what we're gonna do is we will use try and catch. Oops, to close this. And now here, what we're gonna do is we will use try here, while true we will spoof the target, and after that we will also spoof the router, and after that we will let's say we will wait for 1 second, and after that we will, after some user entering keyboard, we will interrupt it. So we will terminate our program. So except keyboard interrupt, keyboard interrupt as error here, or we can also just write E here, and also after that we will print the program is terminated and run successfully. That's it. And after that we can also run our program again. Let's cdt pycharm ls cdf typhoon, and here we have the main.python file. We will use the sudo again, python 3 main.py, enter the password. That's it. And as you can see here, we are waiting 1 second to spoof the router and spoof the target IP address. In this case, the target IP address, actually let me go over here. In this case, the target IP address is our Windows 10 machine, which it's online now. I will show you right now here. And as you can see here, now we will use the ARPA, and we will see some weirdness here. Now what we're gonna see is ARPD here, so delete this. Oops, ARPD, that's it. ARPA again, ARPA, and here, as you can see here, we have this IP address. Now we will go back to Kali machine. We will also check this ARPA, and as you can see, we only have one ARP, which is the target here, which is the router here. Target is our Windows 10 machine here. So and also you will need to import a time module. Although our spoofing programs looks complete, there's a slight problem. So if the victim now tries to request or go to some internet here, our victim, our target machine, will see an error. So let's try this out, and you will see if we can't enter the internet actually. As you can see here, we are just waiting and waiting. We don't have reach to the internet here. So this is because the packets we are going, the packets that are going to the Kali machine, but it's blocking packets from being forwarded, as you can see here. So to enable packet forwarding, you should run the cctl command on your attacker machine. So now we will open the terminal and we will do sysctl here, w net ipv4 ip forward 1. Oops, of course we need to use the sudo here, and as you can see we change it to 1, and now, and as you can see here, we have reached the internet. So this will enable IP forwarding on the Kali machine, and now our target user will be able to access the internet without even noticing that someone is intercepting their traffic. So in next lecture we will monitor that traffic intercepting with Wireshark, and the next lecture is actually more interesting. So I'm waiting you in next lecture. Hello, my name is Tayfun, and in this lecture we will intercept that traffic here. So in previous lectures we did some advancements to this program here. Now we will open the Wireshark to see what the user is doing. So here we will go to Wireshark, or you can also start Wireshark from your terminal and enter the password, because Wireshark wants to run on sudo privileges. And here after that you will select the ETH0 interface here, or you might VLAN 0 in this case if you are using wireless. And what we're gonna do is, let's actually stop intercepting traffic for now. We can also use, actually let's make it more here. So now what we're gonna do is, in Wireshark, remember, actually we learned about how Wireshark works. In Wireshark here, this is the filter. So you can apply your display filter to here, and to see only the traffic originating from Windows machine, you can set this filter, set this from the filter menu here. So what we're gonna do is, oops, Wireshark, I think it's got crashed. Our system resources is not that much here, so these things might happen from time to time. So let me actually fix that. Perfect. Yes. So here ip.src we're gonna do, and remember what our IP address of our Windows machine was. It was, I think it was the IP or ARP A, and here we're gonna see our Windows IP address here. So this is our Windows IP address, and now what we're gonna do is, this is here, and we can also, no, this is actually our Kali Linux machine IP address here. No, yes, this is Windows, and 139 is Windows IP address, and 138 is our Kali Linux attacker's IP address. So we can also check. Let's actually, for now, let's reach to the system and check this IP with ipconfig here, and as you can see, 139. So we will not touch any systems here. And now so we can also find the HTTP login page for now, but now actually let's go for now. Now what we're gonna do is, we will add this IP address to here. So 192.168. So we will enter our target machine IP address as we spoofed here, and we also need to run our program here. So actually it's running here in the background, as you can see, from 1 seconds, so every 1 second we are executing these functions, both spoof target and spoof rudder, and after that we are sleeping 1 second here. And now what we're gonna do is, let me open the recording program to see if you are seeing our Windows machine clearly. Yes, perfect. And now what we're gonna do is we're gonna go to terminal. As you can see, it's running. We're gonna go to the second tab or Wireshark here, and as you can see, we will add our target IP address. So it's gonna be 13.139. So our IP address, I hope, no, as you can see here, pretend to be that IP one. As you can see here, our IP addresses is changed, so we will change our target machine IP address to this, because every time you turn your computer off, if you are using the DHCP server and not static one, you will get this kind of problems. But it's not actually big problem. You can just scan the network and you can easily find that IP and MAC address of the device. So as you can see, actually you don't need to find that MAC address twice here. Here, as you can see, this is the 235. This is the router's MAC address, and we will get that here. This is the target MAC address, target machine, Windows 10 MAC address here, and here let's actually check if we already have same MAC address. Yeah, perfect. We have the same MAC address here, and we will pretend to be that IP here. So in this case, we will make this 19139 here. That's it. As easy as that. And now we're gonna run this program again. Perfect. And here we will go to here and apply that filter. And as you can see here, we send we can intercept the traffic here, and let's go to somewhere in our Windows machine and let's see what will happen. So we'll use some Google Docs here, HTTP here, and we will also use the admin here. So we will go to some admin page here, and let's actually here we have to start the intercepting from that. Well, we are having a quite problem with this program here. Now we're gonna copy this here, but without saving. Open Wireshark again, enter password, that's it. And now we're gonna go to eth0, and here we will apply the filter. In this case, the filter was ip.src, and this filter here. Perfect. Now we're gonna go to, as you can see, it's recording, adding new incoming destination. We can see the source, destination, and protocol here. In Windows, now we're gonna go to, as you can see, we have some here university login page. So we will not do anything harmful to this page. We will just enter some info. So this is our special username and password, some super magic password here, and I will not see this password, and as we will get error. So now we will go back to, as you can see here in Kali machine, we are getting some new connections, so we can stop this here. And now here we should see the packet arriving in this Wireshark here. So now we have this here and login. So we have and here we will apply some filtration again here. So we will add So as you remember, as you know, the most login methods using post here. So we will use HTTP request method is going to be post here, post, and here let's apply that filter. Perfect. And after that we will also add and here. Also we can also start continue without saving here. Oops, sorry, we need to do that again here. Sorry, actually this is our special username, and let's enter some password. No matter how hard our password is, we'll gonna able to see it. Now we will go here. Oops, actually we can open this and we'll go to here, and now we will stop the intercepting, and after that we will enter our filter methods. So now we're gonna do http dot request dot URI path contains login. Yeah, that's it. And after that we will gonna be able to see it. Oops, sorry. Okay, so here we'll delete this, and as you can see we got nothing here. So in some here you might get an error for this, or you might get nothing because you would want to use different filtration here. So we can also make it more this, and as you can see we got this here, and as you can see here we have this. As you remember, this is the IP address of our LMS website of some university. Here we can see a lot of information about it, the frame length, frame number, destination here, source, and here we will see our information. Let's right click on it. We can also protocol decode here. Okay. And here we have a form items. And as you can see here, this is our passwords, right? So let me actually here. I think you can see it here, right? We will take a screenshot now. Oops. Let me take a screenshot right here. And now, here, you will see it right now. As you can see here, this is our special password, special username, and also we have a password here. So this password might be quite hard for to brute force or something, but we got it easily. So this is how our Wireshark and Python program worked, and I am waiting you in next lecture. So we can also do another website here, but for this lecture I think it if it will be more practical lecture for you, and you will understand better how this procedure works if you do this by your own. So I'm waiting you in next lecture.